Okay, welcome to class 12. We're going to continue down the path of looking at tile-based worlds. Before I do that, however, there has been an announcement about the midterm exam, so you should probably look at that. That will be after spring break. So take a look at that and make sure you understand when it is, and the requirements for that. There's a study guide that's posted to the course site, so take a look at that. Also, the letter has been posted to the course site as well, so you can either read the announcement on there, read it in the email. Should say the same thing, but be prepared for that. Look at the study guide. All right, let's get into what we're going to cover today, and that's the stuff for tile-based worlds. We're going to continue that. And as a quick review, here are the examples we've done so far. And if you forgot any of this stuff or want to go back and look at it, go back and look at the previous few lectures. We've had 3 so far. We've done 3 example programs for each one. So lecture Tile-Based Worlds 1 did these first 3. And then we've added stuff to it to do these next 3. And then the last lecture, Tile-Based Worlds 3, we added this. Now what we're going to do today is we're going to add to that. But before we do that, let's look at where we finished up quickly. So let me just quickly switch over to the program as we had it previously. So here's where we finished up. I move this so you can see all of it and see more of the code anyway. Put that there. And let me expand this so it's not showing the background through. So probably right about like that. All right, so you should be able to see what I'm doing now. And if you look at what we did before, what we had finished up with, we added kind of this tile map. We had this kind of universal tile map setup where we can insert additional things into the object that the tile map class that tell what are the tile sizes, how many wide, how many tall is it. We're going to continue that here. But notice how simple our main program is now. All the tile map stuff we moved over into its own module. And let me quickly pull that up here. Let me just do a file open and open the tile map module. And so here's what the tile map module looks like. And you'll notice the last thing we did is we put this tile width, tile height, map width, and map height. But one thing we don't have is we don't have those being stored in our file yet. We probably want to add the ability to store the tile width, tile height, map width, map height in that file format as well. So we can load that up and it knows how many tiles wide it is, how many tiles tall it is. We're going to deal with that today. Before we do that, let's go and take a look at where this finished up. So where this had finished up was we ended up with this program. There's our tile map. There's our little character that moves around. It can collide with the tiles in that tile map. We had optimized the collision so that we are rendering only the or not rendering, but we're only looking at areas around the actual character for collisions to happen. And we have all the other stuff. And this is all being loaded from that thing. And notice we also played around with making a new tile. We made this blue one. We spray painted TNT in there in a paint application. And then we loaded that as a new texture into that. So all of the stuff that's being loaded now is coming from that file. We're going to extend this a little bit today. So let's go back to the presentation just for a second here. And we'll look at how we're going to extend that first. So the first thing we're going to do is we're going to be modifying both the tile map module and our main code. But what we want to do is we want to modify this to work for large tile worlds. And then to give you a kind of an overview or roadmap for what we're going to cover today, we're going to modify it so that it works for larger tile worlds. So rather than just one screen worth of gameplay, we can have a much larger world. So think of games like Terraria, where you have this large world. You run around in it. The world scrolls or pages or something like that. There are a whole lot of games that work that way. Pretty much if you've played any game on the original NES, like Super Mario Brothers, that's how it works. Large world, scrolls around, or pages. Sometimes it goes to like the underground world, and you go back up. So it kind of does a combination of paging and scrolling. But we can do any of that stuff, but we need to get to the point where we can have these large worlds to do that. So after we create a large world, we're then going to move on for example 11. We're going to add scrolling for those larger tile worlds. And then we're going to add a camera that kind of tracks the player as they move around the world. And before we do that, though, let's talk about how that larger tile world is going to work. So the idea here is that we want a world size that's larger than the screen itself. In other words, just like where you're sitting now, there's what you can see, but there's a whole world outside of where you can see. And you can get there by moving around. You can move around within a much larger world than the room you're sitting in right now or what you can see right now. So what we need to do is use a screen that's kind of a sliding window on that world. So in other words, if we have this really large world, we have the screen that we can see, and as we move around, we're going to want to slide that window around on top of that larger tile-based world. And what we're going to do is, in cases where we want to have that happen, we're going to keep track of all the game objects, not on where they are on the screen like we have been. So rather than thinking of it as an X and a Y position on the screen, we're going to think of it as its a location in the world, which brings the concept of world coordinates, that this thing is at this place in the world. And you'll notice you're probably used to that in your daily life as well, that this thing is at this longitude and latitude. Where that doesn't have anything to do with where you are, it's just where it is in the world. But where you are, I see that thing right there. That's this far away in my field of view. It's kind of in the center. If I look back behind me, there's a dog back there lying in the sun. On the screen as it shows up here, it's right there, but it's somewhere else, right, well, I don't know if you can see that or not, but right there. But it's somewhere else in the actual world. So the idea is that we want to keep track of game objects using world coordinates, but then we have to at some point draw them on the screen, so we need to convert them to screen coordinates to draw them where they belong on the screen. And so the idea is we need this fluid way to convert back and forth from world coordinates to then draw it on the screen in the right place so that it shows up. So let's look at how we would do that. So let's start off with this example. So let's say that this little blue circle here is our eyeball in the game, and it's that's being kept track of in a world coordinate. So let's say this outside frame here, this big frame, that is our world coordinates. So this is our world coordinates. This kind of gray frame here. I don't know why this has a border. It's not supposed to. Let me see if I can get rid of that. Okay, that's better. So now we don't have an extra frame around there. So this is the world space. And then we have this sliding window that I have labeled as screen, which is kind of a window into that world. And that is the window where it is right now. It can slide around on top of that world. So think of that as like a little frame of a camera that you can move around on top of the world to see just certain parts of it at one time. Now, the eyeball's position, our character's position, we're going to keep track of that in world coordinates. So in other words, the X is how far over in the world it is. The Y is how far down in the world it is. But notice that that's going to put it somewhere on the screen, or it could be that this is so far over and so far down that it's off the screen altogether. So some objects might be on the screen, like this eye where it is now, but if we moved it to the right, it could go off the screen. Now, where is that screen, that sliding window? Well, we need to keep track of where that is. So we're going to keep track of this upper left corner of that. So that point right there, that's a certain number, that window is a certain number of X units over in the world, and it's a certain number of Y units down in the world. Now, it's going to have a width and a height, so we can draw the thing. But notice that this WX and WY represent this top left corner of that sliding window. So if we put it at 0, 0, it would be all the way up here. If we move it over and down a little bit, WX would increase, WY would increase. So we're going to slide that down. So notice we're going to be able to slide that window around to where we want. But what we need to do to render things, since we render things only to the display surface, to the screen, we need to convert from world coordinates to screen coordinates to have that show up. And believe it or not, we have all of the information we need right here in this picture. So how do we convert from world coordinates to screen coordinates? Well, let's look at that. How far over is this on the screen? If the screen's to upper left corner is WX, and IX is in world space. How far over is that on the screen? Well, it's just the difference between this edge over here, the left edge, and the X coordinate of, in this case, that eyeball. So how could we compute this distance here? Well, let's take a look at that. So let's take an example. Our world is 50 tiles by 36 tiles. So in other words, 4 screens, twice the horizontal number of tiles, twice the vertical number of tiles. So it's kind of like 4 of our existing screens stuck together. And each of the tiles is 32 by 32. So we end up with a screen that's 800 by 600 pixels, just as we have been. That's a window in that, so it obviously can't see everything at one time. Now, this stuff doesn't really matter to us right now for doing the computation, but let's say the I is at 1,000, 1,000. So this is IX is 1,460. So IX is 1,000 and IY is 460 down. That's in world coordinates. And the screen upper left corner right here, this position right there, is a WX of 800. So window X of 800, window Y of 300. So now where is this on the screen? How can we figure that out? Well, the answer to where that is on the screen, it's at 200, 160. Okay, so how do we get that? How do we compute that 200, 160? So in other words, this is 200 pixels over. How can we compute that given the window position for the upper left corner and the eyeball's position for its center? How do we know where that center is when we draw it? And the answer to that actually turns out to be just a simple computation. We just need to compute the difference between these two. So how did we get that? Well, we had the I at 1,000 X, the screen upper left corner up here, upper left X of 800, so 1,000 and 800. So we just basically take the I world X and subtract the screen corner X. So in other words, in this case, it's going to be IX minus WX, or 1,000 minus 800. That's where that 200 came from. And we do the same thing for Y. We take the I's world Y, which is IY, and subtract WX from that. So in other words, we're going to take 460, subtract 300 from that. That's going to leave 160. So that's where we got that 160 up there from. So notice this idea works with any kind of general conversion from world coordinates to screen coordinates. In other words, we take the object's world X, subtract the screen upper left corner X, that gives us the object's X position on the screen. And we do the same thing for Y. We take the object's world Y, subtract the screen corners Y, upper left corners Y, that gives us the object's Y on the screen. So we can convert any object from world coordinates to screen coordinates using just this simple subtraction like this. Note, sometimes, however, you're going to wind up with negative numbers or numbers that are outside of the range of the screen. That's okay. We can either render them even though they're off screen and they won't show up, or we could say, hey, if these things are off the screen, just don't render them, don't draw them. We're going to look at some optimizations doing something like that in a little bit. Okay, now there are cases where you want to convert the other way, where rather than just going from world to screen, like we did back here, which is more common. And the reason that's more common is because that is whenever you're going to render something, you say, here it is in the world, we want to draw it on the screen. The screen might be a moving window and move around, so we need to compute that every time we go to draw something on the screen. The good news is, really simple computation, it's just a subtraction. But if we want to go the other way, what if we want to take a screen coordinate and then convert that into where it is in the world? So in other words, we want to know what world coordinate is associated with some point on the screen. And the most common use for that is if you want to have a game where you click on something in your world with a mouse, where you say, select this. And if you've ever played one of the like Civilization games or something like that, you want to click on one of the troops and have it do something. Or there are tons of games like that where you want to click on something and add things to that in the world space. But so you need to know, when I click on the screen at this point, like let's say right here, where is that in the world? What place in the world is that? So we need to compute going the other way. So to do that, we're going to use the same relationship we already did, but we're going to solve for the world coordinate. So let's take a look at how we would do that. So if we use that same relationship, here's what we had before. We just solve for world. So in other words, we're going to be given screen and the screen corner, and we're going to solve for world. So to solve for world to get this on a side by itself, well, easiest way to do that, add screen corner x to both sides. These will cancel out. Over here, we're going to have the screen corner x added to object x screen. So we just solve for the world coordinates in each of these, and we get this relationship we have down here. Very simple algebra. So in other words, to go from screen coordinate, we just say add the object screen coordinate to, or the not even necessarily an object, but add the screen coordinate we're interested in to the object's upper left, or the screen's upper left corner. That'll give us a place in the world coordinate system. So doing that for both x and y, we now have this fluid way to convert between the two different coordinate system types. If we have a screen coordinate and we want to say where is that in the world, we do this calculation. If we have a world coordinate and we want to know where does that show up on the screen, we do this calculation. And notice how simple they are. It's not overly complicated. It's just one of them is a subtraction, the other one is an addition. And quickly looking at that again, that makes sense. We're basically, when we're going from world to screen, we're finding the distance over here and the distance there. Going the other way, when we're on the screen, we want to find how far we are from this. So we know how far we are from that upper left, so we just add those together to get that. So if you just remember this diagram here, you can reconstruct this without having to remember these things here. It's very straightforward conceptually and mathematically. And the good news is that's going to translate to it being very fast. Okay, so let's work on our program version 10. Let's get started on those little programming tasks. So we're going to start off with this one, making that map file larger. So we're going to use that 50 by 36 tiles thing first. So the first thing we're going to do is we're going to modify the map file. So we're going to edit that map file. And then the next thing we're going to do is we're going to add keys to the map file to keep track of the tile map width and height and the tile width and height, because we want that to get loaded when we load the map up. And we're going to, then what we're going to do is after we edit the file, we're going to edit the load map from file method in our tile map class, and we're going to add the ability to load these parameters in addition from the file in addition to the other ones. So that's going to be our first starting point. Now I've got two dogs back there, if you can see. Oop, wrong way. It's two dogs. They found a patch of sun. My other class, they attacked. They decided to have an argument with a cat, which is over that way. It's craziness. All right. So anyway, here's what we're going to do. We're going to start with this stuff. So let's go ahead and get started. Let me bring that code up that we were editing just a second ago. So let me switch over so you can see that. And we've got two different programs there. That we're dealing with. And let me make it so you can see that. Okay, so here we are with tiles 9. So the first thing I'm going to do is I'm going to, I'm actually going to go to the my file system here, and I'm going to make I put all those in one directory. I'm going to copy that. I'm going to copy that entire directory, and I'm going to call it, instead of tiles 9 copy, I'm going to call it tiles 10. And the reason I'm doing this is, and rather than just saving it as a different source files, we now have two source files. We have a tile module, tile map module file, and we have the actual program itself that we're dealing with. So I'm going to go ahead and, here, let's close this out. Close out the programs we already have open. And I'll reopen those from this one. And I'm going to rename this tiles 10. And now let's go ahead and open those and start editing it. But before we edit the actual code, I'm going to edit this map file. in this Tiles 10 version. So I'm going to go ahead and open that with, let's just open it with Notepad. All right, so there it is in Notepad. Now we know the things that we want to change. And as a quick review of what we want to add to this, let's go back and take a look at this real quick. The things that we want to add to this are make the map larger using a 50 by 36 set of tiles, and we want to add these keys. So to keep in mind, we want to add those keys. Oops, let me bring that Notepad file back up. Not that one, this one. So we want to make this essentially twice the size that it is here. That means we have to have twice as many lines. So let's just start editing this. So twice as many lines. I will copy all those. But we also want them to be twice as wide. So I'm going to do that. I'll just copy all of this code that's in here. This is going to take just a little bit to get started on here. And the same amount of code in here. And here, I'm going to go through and do the lines here that are familiar to us. But notice this is just twice as long as the previous one. And let me copy this one with these platforms in it. This one has its own platform in it. And you could just draw this out, I suppose, by hand. But I'm going to basically just connect these together, which is duplicated, and then we're going to edit and add some little passageways through. And if I was using a better editor other than Notepad, then I could actually copy blocks of text. Like, for example, Notepad++ allows that. Maybe I should have opened it in that. Save us a little time. So as you can see, now I have pigeon noises. So I have dogs, cats, pigeon noises. All right, so we're almost done here. Okay, there's that. Let's add some passageways so we can get between these different levels in some way. Let's make an opening here. That might have not been the best idea. Let's do that. And I don't know, maybe we'll make a little opening up here. And let's make a little passageway that we can walk through here. And let's make an opening here. Let's put a little platform here. And then let's make an opening up here. Okay, so now we have a map that's a little more joined together, making a much larger maze. So let's just do a Control S on that to save it. But there was one other thing, remember, we needed to do, and that is we need to add these keys to our map file. So we already have our textures in there, wherever the map lines in there. So what we're going to need to do here is we're going to need to add tile map width, and in our case, that's going to be 50 tiles wide. Tile map height, we need that to be 36 tiles wide. Tile map, or tile width, each tile is going to be 32 wide, and tile height, each tile is going to be 32 wide. So there's our file. And I'm kind of not happy with how I have this bicapitalization going on where I'm like camel case, where map line is all lowercase, but tile width, tile height, load texture all have that cap. I'm going to fix that as well. I'm going to change this to map with a capital L. I suppose I could have done a search and replace, but I'll just do it this way. And I'm going to change that in my code too to support that. And really, if we wanted to, we could make it so that code doesn't care if those are uppercase or lowercase or how they're capitalized. Might be a little bit safer to do it that way. Add a little more robustness to the loading. So if somebody accidentally spells something with the wrong capitalization, it doesn't break the whole system. Okay, so there's our new tile map file. I'm going to go ahead and do a Control S on that. So let's make sure we did all the stuff we said we were going to. We definitely made the map larger. We made it 50 by 36, 50 wide, 36 tall. We then have the tile map width as 50, the tile map height is 36 to match the size of that map, and we added keys for all four of these things. The last thing we need to do is have this load map from file method, and our tile map class, we need to do something with that. So let's go and take a look at that code. So let me go back to my tiles 10, and let's actually open both tiles 10. So the main program we're going to use to test it, and I'm going to change this tiles 10. And I'm going to add some more comments here for what we're adding. That's what we're doing there. I'll do a Control S quickly. Now let's open the actual tile map module itself, which is right there. We'll open that. And this one, what we need to do is we need to add the support for loading these things here when we load that file. So down here in the file, that's just additional keys that we have here. So here, map line, there's load texture. We're just going to add some additional things in here. So I'm going to say elif key equal, and I'm just going to paste those in down here, and we're going to do those one at a time. So in this case, if it's tile width, if that key was in there, then we are going to set self.tilewidth equal to whatever the value was. But we can't set it to just value like this because value as it comes in is a string, so we need to convert that to an integer. Like that. And we're going to do the same thing for height. Oops. So that takes care of that one. And now we need map width and map height. And I believe that I saved those in the file under tile map width and tile map height. So let me verify that. Let me go back and take a quick peek at the file. Tile map width, tile map height. Yeah, so let's go back to our code. This is going to be tile map. Oops. Tile map width. This is going to be map width. I usually don't like those to be not match up, but we kind of got out of sync a little bit. We could fix that here in a little bit. And then tile map height is the same as map height. All right, so now we have that new way to load those. And you'll notice one thing that we probably want to do in our file is we probably want to load the map width and map height, tile map, or tile width, tile height, tile map width, tile map height. We probably want to do that before we do the load, the stuff that loads the map line. But the way that we have done this here is notice that we will have processed all of the lines here before we ever call this tile map from string. So really it doesn't matter what order those are in the file, because this is just reading all of the file, taking any entry we have. Also notice I don't have any error reporting in here. We might want to have an else that says, hey, if this is a key that doesn't exist, report that. So if somebody spells something wrong. So it's not real robust right now with reporting errors when they happen. We're just expecting it to have, anytime it has these things, those things will get used. But now we have all of those things have keys in the file. Let's do a Control S on that to save it. And let's go back to our tiles 10 and run that and see if we screwed anything up. And we did not. Here's our map. And you'll notice that it loaded the right map because there's stuff missing here. And there's stuff missing down here and over here. And notice that I can actually leave the screen now. I can go off the screen. So I'm off on the other part. So I don't have any scrolling in yet, but I'm definitely over there in this larger map. And this works the same as it did before. And I can actually just drop off the edge here. Unfortunately, I have no idea where I am now, so I don't know that I can get back. But, oh, that was luck. So I did actually jump back up. I think I've fallen down somewhere now. I have no idea where I am. All right, so that takes care of the first part. So we have this larger map. So let's go back and look at our task list again for that first thing. So the first thing we wanted to do was this stuff. So that was version 10. We got all that working. We have the larger map. Now, version 11, we want to modify this so that we can actually scroll that window around on the screen to look at a different place. So we're going to modify. We also want to means if we're going to have that sliding window, we're going to want to modify that tile map renderer to use the window position so it doesn't always draw it like we saw here with it always drawn in the upper left. We want to be able to move this window. Right now the window is at 0, 0. We're going to want to move that around so that the window can show up at places other than 0, 0. So we could actually follow the eyeball around or have the camera look at other things in our world other than just the uppermost left corner of it. So right now the window is at 0, 0, so it's right there. And it's not at 0, 0 because we set it to 0, 0. It's at 0, 0 because, well, that's kind of where it is right now. There's no window implemented. So let's add that to our code first. So what I'm going to do is back in my tile map module, so right here. Well, before I do this, this is going to be a new version. It's going to be version 11. So let's go ahead and go back to our file system and copy that. So that way, when I post this, you'll have those. So I'll just do a Control-C on that, a Control-V, and we'll change this to tiles 11. And I'm going to close these two out. I'm going to go into tiles 11. And I'm going to go and edit or change the name of this guy to tiles 11. And the only reason I'm really doing all this is so you have the kind of snapshots of each of these development things as we created them. And now let's go and edit that guy. Let's change the name of it, 11. So what are we adding to this? We're going to add support for that window, that scrolling window, sliding window. And window, rendering it based on the window position. All right, so that's essentially what we're doing for this version 11. I'll go and save that. I'm going to do a file open and open the module since that's where the changes are going to be. Oop, that's not what we want. Open. Tile map module. All right, so how do we add that window to this? So to add the window to this, the idea is we're just going to need some things in our class to keep track of that. So all right, so those are the things I'm going to add. So window X, I'm going to just start this off at 0, 0, which is essentially what we have right now. And then window height, we have an 800 by 600 window, so I'm just going to hard code those for right now, 800 by 600. So we added these, this window X, window Y, window height, or window width, window height. Those are the things that we just added. Now, because I've added those and I want that window to slide around, I want that to be used when I perform this rendering. So when I do render tile map here, and I'm going through and rendering, blitting all of those objects, I want to convert that and blit that or draw that thing to a particular location on the screen. So right now, notice I'm just saying, hey, take the column, multiply it by the tile width. But this X that's being computed here for this blit position and this Y that's being computed in that blit position is not taking into account the screen location. This is in world coordinates. So this is we have this really large world, a really large number of columns that are going across there. This is taking into account entirely kind of the world position. So how can I get this to take in the screen position into account as well? Well, if we go back and think about how we did that, these things need to have that screen position, this world coordinate converted to screen coordinates. And let's quickly go back to here and look at how we did that. So let's go back a couple pages here. So how did we do that? World coordinate to screen coordinate, we just need to subtract that screen corner X from the object world X. In this case, it's the position we're blitting that tile to. We're going to move it based on that screen corner. So all we need to do, going back to our code here, is say minus self dot window X for that one. And for row, self minus self dot window Y. Now we also need to change that down here. Minus self dot window X minus self dot window Y. And since that's the only place where anything is blitted, let's go ahead and do a Control S on that and save that. And let's go back to our main program and let's run that. And you notice nothing has changed. And that's what we want, because right now the window is in this upper left corner X, upper left corner Y. But watch what happens if I'm going to add something to my main program that allows me to move that window independently. So let's allow, let's allow some keyboard input to, here, I'm a little off the screen here, hold on. Let's allow some keyboard input here to actually move the window around separate from the eyeball. So right here, I'm just going to add some keyboard input to move that around. So I'm going to say if keys square bracket pygame.k underscore. Let's use the actual arrow key. So I'm going to say left. So if they press the left key, then I'm going to say, let's see, this is tile map 1. That's the name of my object, dot window X minus equal 1. And then if they press right, so this is the right arrow, then plus equal 1. And let's do keyboard up. So the up arrow, that would be Y minus 1. And down, we'll do window Y plus 1. All right, let's see if that actually works. So we'll run that, and there's my window. Now if I press the arrow keys, notice there's the left arrow, right arrow, up, down. I'm actually moving the window position around. Now notice there's some problem here. Notice the eyeball. The eyeball is not moving with that. And that's because the eyeball code is just on screen coordinates only. It's not taking into account the window position right now. So let's fix that. And now we have a way to kind of scroll around and look at the entire world. But the problem is the eyeball is not being converted to screen coordinates, taking the world into account. So we need to do that. And let's find where here's where we're rendering the eye, right there. And what I'm going to do is, rather than doing that in its own function, since it needs to take world stuff into account, I'm going to make a function that's part of my tile map module that's going to allow me to render things in that world. So I'm going to go back to the tile map module, which is here. And I'm going to add a method. We have render tile map. Let's add one here for def render object self. And here I'm going to pass in a world X and world Y. And I'm going to pass in Actually, before I do the X and the Y there, let's pass in the surface. And that's going to look a lot like what we already did over here. So I'm just going to copy this line. So we know we're going to split on that, but it's going to be a self, because the display is part of this, so self.ds.blit. And here, this is going to be surface. That's the surface we're blitting. In that case, it's going to be the I. And here, this is going to be world X, world Y. But remember, we need to convert that to the screen X and screen Y. And if you remember the way that we did that just above. We just need to subtract the window from that. So here, minus self dot window X minus self dot window Y. So now we've made this function that will always take the world coordinates, convert it, take the surface and the world coordinates, convert them to screen coordinates, and then blit them onto that surface. So now over here, I'm going to call that Renderobject function back in here. So rather than render I, I'm just going to get rid of that altogether. Wherever we're calling render I, which is down in my main program down here, we're going to call tilemap1.renderObject. And what we're going to pass to that, as a reminder, is the surface we want, which is going to be that I surface. And then here, the location, IX, IY. And let's see what happens. All right, so apparently, did I not save that? I need to do a Control S on that and save it. Try again. I just didn't save. And there we have that. And now let's move the camera around. And now you notice the eye moves in the world where it goes. So we have kind of independent camera control from the object control. And it's just that simple subtraction that we did earlier. Okay, let me move this down so you can see the whole window. So now I can, object can leave the screen. Is it still there? If I scroll over, there it is, it's still there. So I can jump up here, oops, and leave the screen. Where did it go? There it is over there somewhere. We can fall off the bottom. Where did it go? Fell down the hole. There it is down there. Let's fall off the bottom again. And whoop, fell through the hole. And there I am down there. So you notice we have this independent camera control now that's moving around on the large world. And the object is moving around in that large world. So the object itself is in world coordinates. It only gets converted to the screen to do the rendering. Now, there's one other change that I want to make to this version of the program. And that is right now the way we're rendering the screen, the world, we're rendering every single row and column of this, whether or not they're on the screen or not. And for this, in other words, right now we're rendering bricks that are all the way up here and all the way over here that are completely off the screen. So we're spending time and effort calling that function to render them, even though we're not going to see them. So we're going to do an optimization to that render code here. And then we're going to move on to the next thing, which is to get the camera to follow the object on its own automatically. So let's quickly add that optimization. So let's look at where the problem is. So let's go to our tile map module. And here's the render tile map function. Notice we're going from 0 to the tile map height. And we're going from 0 to the map height. We're going from 0 to the map width. Well, the question is, why start at 0 and go to that if 0 is not visible on the screen? So if 0 is not on the screen, there's no reason to go to that. Or why go all the way to the height if we get to the one that's off the screen? So the thing that I'm going to do here, or that I think we should do here, is look at where the upper left corner is relative. Is it on the screen or not? In other words, we want to just go through the range of tiles. Why start at 0 if we're 10 tiles over? Why start at 0 on the column, or if we're 10 tiles down? Why start at 0 on the column if we're 10 tiles over? Why go all the way to the height if we only can see the first 25? So the idea here, and I guess the main thing to note here is that we want to compute this range dynamically based on where our screen is. So I'm going to pause here for just a second. There's a strange noise. I think the cat might be doing something. So I'll pause this and I'll be right back, and we're going to add that code to optimize this. So before I leave here though, there's the comment that we're going to fill in a second. So I'm going to pause and I will be right back with doing that. Okay, we're back. It apparently was not the cat doing something bad. It was something outside, some sort of construction or something like that. Sounded like the cat destroying something. Anyway, now we're ready to add that optimization to our code. And that's what we said we were going to do before. Let me make sure you can see all of this window. All right, so to add that optimization, the main thing that we want to do, the thing that we want to watch out for, is we don't necessarily need to start at 0. We could start at something else. What I'm going to do here is I'm going to compute that. So I'm going to say, what is my row top? What's the top row that's visible? And the way that I can figure that out is I can say, well, I know what my window y is. So self dot window y. And if I know how big the tiles are, then I can say divide that by, in this case, that would be self.tile. This is y, so height. And if I take the int of that and get only a whole number out of that, then that will tell me. And really, there's another way I could do this as well. I can do an integer divide by //. I don't know if you learned that. But that's an operator that gives you the whole number result from something. But this row top that we have now, essentially what that's saying is take the window y, where we are now, divide it by the tile, or the y, divide it by the tile height, and that tells me which tile I'm starting on. So that tells me which tile does this window y start on. Now, there is a problem with that, though, and that's the window y could be moved up so it's negative. So we need to check for that. So I'm going to say if row top ever gets to be less than 0, then row top equals 0. Okay, now that handles the top. Now, what's the row bottom, though? We need to compute that. So here, row bottom. And the way we're going to compute the row bottom is that's going to be row top. So row top plus, we need to figure out how many, how far over that needs to be based on the window height. Remember we saved window height, that 800 by 600. So if I say take the row top and then take self dot window height, because this is y, and divide that by self dot tile height. And then we'll take the int of that. Then that will be my row bottom. Now there is something that's going to happen here, and that's because there's something that we're going to have to deal with, which we'll see in a second. But then down here in my row, I'm going to change this from row top and make it go rather than to the map height. We're going to go to row bottom. And just like we had to contain, had the problem where this could go off the end, if the window is moved so that the tiles would go off the side, we need to check for that as well. So here I'm going to say if row bottom ever gets to be, in our case, it's going to be greater than the width of the tile, the number of tiles. So that was that self dot map height. Yeah, that should be right. So if that's ever the case, then we want to say row bottom equal self dot map height. All right, now that does that with the rows. We want to do the same thing with the columns. So I'm just going to copy this code here. We're just going to make the changes we need to do this. Instead of row, we're going to change that to column. And here instead of y, it's going to be x. And here instead of tile height, it's going to be width. This is going to be column. And that's going to be column. And this is going to be column bottom is going to be column top plus int self dot window width divided by self dot tile width, and column here map width and column bottom. And then down here in my code, so notice what we're actually doing here is we're setting the range that we're running through on those. So we aren't rendering tiles unnecessarily. And then here, this is going to be the column is going to go from the one column, and maybe I shouldn't call them top and bottom. Actually, let me fix that. Instead of column top and bottom, this is the column left. That might make more sense. Left, 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 and then here, rather than bottom, it's going to be right. That's a little more clear, I think. So in other words, we're saying this is the top row that's visible in the window, going through the bottom row that's visible in the window, and then the column we're saying start at the leftmost one that's visible in the window and go through the rightmost one that's visible in the window. So down here, this needs to be column left to column right. Now, I may have screwed something up there. Let's do a Control S on that to save it. And let's go back to our Tiles 11 program and run that. And it works just like it did before. Let's make sure the scrolling behavior still works, so we can still scroll with the arrow keys. Now, here's where I said there was a problem. Notice that there's that thing where it's kind of blocking and filling in as we go. And that's because we're going to the rightmost one, but until I get more than halfway across that, it doesn't show up because it's using that integer division. And the same thing can actually happen, or should be able to happen on the bottom as well. And notice that kind of blockiness where it's kind of chunking in like that. You've probably seen games that do something like that. But the same thing should also be able to happen on the bottom here. Should we look okay on the bottom? Let's just on the right that's a problem. So how do we fix that? Well, we need to just make it go one more, or maybe it happens on the top. Let's see if it happens on the top. No, we're okay. Oh, yeah, there it is on the bottom. So notice that blocking in, pow, pops in. So we need to fix that so it's not chunking in those things like that. And the way we need to do that, it's actually pretty simple. The solution to that is back in our tile module, which should be back here. The problem is that when we're computing the row bottom, we're taking the row top and we're adding that amount to it. But since that can be slightly offset where we're not getting a full tile, we're just going to add a +1 on the end of the row bottom and a +1 on the end of the column right. And let's see if that works. Oop. I need to go back to here to run that. And there it is. And now you'll notice we should get that one off that way and the one off the bottom. Notice I did lose that little area at the bottom where I could store my heads-up display. Notice it's still chunking in at the bottom. So we probably ought to fix that. So we need to actually do +2. Let's see if I screwed that up or not. Yes, I think these need to be +2. All right, let's check that out. Okay, now I think we're good. So no blocks chunking in side to side, none of them going top to bottom. And this smooth scrolling. All right, so that is program 11. The last thing we need to do, or that we are going to do here is, let me close that guy out for a second, is we want to copy all this again, and I'm going to make 12. So let's go up. Let me do a Control-C. Let me do a Control-V. Change the name of this to be tiles 12. And I'm going to enter that. And in tiles 12, I'm just going to change the name of the program. And the last thing we want to have added, let's go back to the presentation just for a second here. The last thing that we want to add, we did that. The last thing we want to add is add this camera look at method to tile map. And what that's going to do is that's going to give us the ability to have the camera follow the player. And let's just quickly add that code to this version 12. So I'm going to go back to the screen view. And we're going to edit this guy. And this is going to become 12. And the thing I'm adding now is going to be I'll just call it that. All right, so let's also open the tile module because that's where the changes are going to be made. All right, so here we are. So we're going to add this camera look at. And really what that camera look at is going to do is just going to change this window X and window Y values that we see here. So it's just moving the window for us. So I'm going to just say def camera look at, and I'm going to pass in an X and a Y, and that X and a Y are in world terms. So I'm going to write that down. So it's world X, world Y. And the idea here is we want that world X and a world Y to be centered in our frame. So to do that, to center those in the frame, what we're going to want is we're going to want to change the window X to be some value and the window Y to be some value. And these are off the screen. Hold on. There we go. So that's what we want to change. But what value do we want those to be? So how do I put that world X position here exactly, this world X here, how do I put that exactly in the middle of the frame? Well, it turns out to be that that is not outrageously difficult. That basically we know how wide the window is. We want that position minus the half or so this world X. So let's do world X, and we want to subtract from that world X half of the width of the window. Self dot window width divided by 2. And there's the window width there. It's 800, so we're subtracting 400 from our world X and putting that at that position there. And let's do the same thing with Y. So world Y, window height divided by 2. So now we have this camera look at that if we just pass in a thing, it says look at this position in the world, it's going to center that in the frame. And how is it centered? Well, it takes that world X, subtracts half of the width, half of the height to move the position of the window up and to the left. And now let's just do a Control S on that. And let's go back to our main program over here for tiles 12. And let's add a thing that looks at the eyeball as this thing runs. So here's this render object, but before we do that, before we do any of this, I'm going to say tile map 1 dot camera look at I, X, I, Y. Since that's a world coordinate, we can do that. And now notice the eye is kind of slaved to the camera is slaved to that eye as it moves around. Now this is a little bit irritating because any little jump we do, the whole world kind of shakes around. So it might be useful to kind of add a little bit of smoothing behavior to this. So the question is, how can we make this so the camera moves a little more smoothly rather than being hard slave to that? And the answer is, rather than moving it inside of that exactly to that position, we're just going to move it towards that position as a percentage of how far off it is from that position where it is right now. So let's actually take a look at how we can smooth that out a little bit. So let's go back to our camera look at, since that's the thing that's actually doing the movement. And we want to smooth this out a little bit. So what I'm going to do is I'm going to figure out how far away my position is now, and I'm going to move it a little bit toward that based on that. So let's add a comment here, and I want you to think about how you do this first. I'm going to pause it and let you think about it. But so let's say move camera towards the desired location. Smoothly. So that's what we want to add. Go ahead and pause it here, see if you can think of how you do that. So the idea is we don't just want to set window X and window Y directly to this. We want to say this is going to be my goal position is this, but I'm somewhere else right now. We want to say how far away from that are we, and we want to move it towards that in some way. So I'm going to pause here, let you think about that for a second, and then when we resume, we're just going to finish this up and have this kind of smooth camera tracking that. The cool thing about this camera look at thing is you can actually look at different things in the world at different times. So you look at one thing, look at something else later. Let's pause it. I'll give you a chance to think about how you would make that move more smoothly, and then we'll finish that up here in just a second. Okay, so we're back, and hopefully you had a chance to do a little bit of thinking about that. But the idea here is going to be relatively straightforward. The idea of what we want to do here is going to be that we want to move that thing kind of slowly. So what I'm going to do is I'm going to compute the displacement from where it is now. So this is kind of the desired position. So let's call it the target. X is that, and the target Y is this. And what we're going to do from here is we want to compute the difference between where it is now and where it needs to be. So I'm going to call that, we've been using dx and dy for other parts of the code, so I'm going to call it the, I'll call it dx for difference x, and the difference x is going to be the target x minus self dot window x. So in other words, what's the difference between where it needs to be or where we want it to be and where it is now? And then I'm going to do the same thing with dy. So dy is going to be the target y minus self dot window y. Okay, so those are my target positions. So if I were to just say here window x plus equal dx, that would move it the entire way to there, and window y plus equal dy, that would move it the entire amount that it's off by. So this would work exactly the same way as it did before. And let's just do a Control S on that and run that and verify that that's the case. And actually it's not moving at all now. Let me look at y. Did I not save? Oh, that's the problem. I had a typo. Let's do a Control S. Let's try that again. That should have worked. There, and now it does the same thing it did before, where it just follows it, kind of a hard slaved follow. Now, the way that we're going to make it a little more smooth, though, is back in the code here, rather than following it exactly and putting all of dx into that, we're going to actually do that as a plus equal dx times some multiplier. So if I do, like, for example, 0.5, or let's do 0.05. So we're only moving it 5% of the way toward that each frame that camera look at is called. Let's do a Control S on that. Let's run this again. And now you'll see we have something that should be much smoother. And we can play with, we can play with what that, apparently that ran it, but it ran behind the thing. Let's try again. And now you'll notice that as I move, the camera follows, but it kind of lags behind a little bit because it's only moving 5% of the way to the goal of where it needs to be. So if I move really fast, I can get the camera moves faster because it's still moving it as a percentage. But notice this is much less irritating to look at than where it's hard slaved. This looks more like the camera, a cameraman is actually operating it and following that. The camera moves fast to try to keep up with it. Now, if we play with that percentage and get it so that it's too slow, let's do that real quick. So rather than 5%, if we do like 1%, now we could actually have a case where we can get off the screen and the camera will lag behind and take a while to keep up. So notice the camera is moving much more slowly. Let's jump up here. Notice that I can actually outrun the camera because the percentage is too low for how quickly it's moving. Now you might want to have that happen in some games. You might want to use that as some sort of an effect in your game, that the camera kind of will lag behind And so let's go back to that 5%. Seemed like a pretty good number. That's the wrong file. This one. And if you want it to snap more quickly, you can raise that number, lower the number to make it go more slowly. Now there are other ways to move the camera as well. For example, you could have it so that the camera, rather than trying to center that thing, it only moves when you get near the edge and it kind of pushes the frame across. I tend to like this because it keeps the center of action centered in the screen. You could also do page scrolling where it jumps to the next page when you get to the edge. But this actually seems pretty smooth. It doesn't make your eye go crazy with the camera following the thing always exactly in the center of the screen. And you can play with that smoothness factor and put it to whatever you want. So I actually tend to like this kind of camera control where it tries to keep the action centered, but if the action goes fast, the camera moves fast, but it's not hard slave to it like it was originally. And this gives us that camera factor. All right, so that's it for today. Let me go back to the presentation. We'll make sure we did all the things that we needed to do from that. And I believe we did. Smooth the location of the camera movement. Other scrolling techniques. We didn't really investigate that too much. We talked about the hard scrolling versus smooth scrolling. There could be page-based scrolling. You could have it scroll by pushing the camera around. We talked about those but didn't add them. But that should be good for what we wanted to talk about today. So that's all for today. Work on your labs. Make sure to be ready for that assignment. I will post all of the source code to the course page. So if you want to download this and play with any of these and look at them, you can kind of follow the progression along in those as well. But that's it for today. Stay safe. Be ready for your midterm. We do have one more thing I want to do with tiles that we'll do. I'll probably post a really quick lecture next Monday. Even though the email said there wasn't going to be another lecture, I'll post another one because there's one more thing I want to do with the tiles, and that's add the ability to have background tiles that have like grass textures and stuff that you can just move across without interacting with them. And I also want to add the ability to be able to detect what kind of tile you're colliding with, which is going to give us the ability to do things like climb the ladders or move across the ladders and know that we're touching the ladders, or make it so when you touch something like spikes, it does damage to the player and so forth. But it's useful to know what kind of thing I'm colliding with, not just that I am colliding with something. So we'll probably do a quick lecture next Monday on that. Or not next Monday, but the Monday before. Maybe I will post it next Monday, even though it's spring break. So you have it. You can look at that if you want to, and you can watch it after spring break if you need to. But be ready for that midterm exam. That's it for today. Everybody stay safe, and I'll see you next time.